describe the setup. I got the video going.
Okay. So what we got going on here is an epicarstic drip study. What we're doing is collecting drip waters off a couple of dozen stalactites, only a few of which really are actively dripping. To get on this tarp, the tarp's about 2.5 feet by about 12 feet long. We're not really concerned with the absolute amount of water coming in here as much as we are about comparing changes in the chemistry and the drip rate over the course of the year. The tarp is tilted, and at the bottom of the tarp, we have a funnel that's mounted into the tarp. The funnel takes the water that lands on the tarp, and it takes it through this tube down to a small chamber constructed out of PVC where we keep our instruments. The chamber's volume, I have to look it up, but it's less than 100 milliliters volume in there with the conductivity probe in it. In the chamber, we've got an onset Hobo U24 conductivity logger, which also records temperature. Temperature, I don't think, is nearly as valuable as the conductivity here because of the contact time with the tarp varies with drip rate. So the temperature equilibrates the cave temperature to a varying degree. So I don't think that's nearly as useful. But the conductivity data is very consistent and very good. It tends to respond to rainfall events, but not all of it. Pretty good. With what'd you say? I'd have to look it up. It's like 400 to like 550 microsiemens. I can look in the notebook when I get up. I make it a little low. Probably a little low. Anyway, the overflow from the conductivity chamber comes into the top of this tipping bucket rain gauge. Tipping bucket rain gauge has a reed switch, which is connected here. Goes to a pulse adapter into a Hobo microstation. The other thing going into the microstation is an air thermometer. So we get the air temperature getting us dangling down right here in free space. So we have air temperature, we have drip rate, and we have electrical conductivity. And those are our three parameters that we're concerned with here. Once the water comes out of the tipping bucket rain gauge, it flows into a sample bottle. The curve is not catching grab samples, but when we do, we can come in here and we can estimate how long, based on number of drips, how much time that grab sample represents. During high flow periods, it's more of an instantaneous sample than during low flow periods. The airlock really doesn't serve any purpose when it's overflowing like that. And then once it overflows there, it goes into that reservoir. We use that reservoir for basically water we need to clean the tarp, that kind of thing. The other big advantage of having that reservoir is occasionally it gets colonized. We'll see Cicadotia in there. We've also pulled some small amphipods out of the drip sample bottle, as well as that reservoir that you see. The site is serviced monthly. Download these using a portable shuttle. That's this portable waterproof shuttle. Fairly reliable. And you take it back to the office and download it. We try to clean the conductivity probes monthly with a weak vinegar solution. We get calcite build-off of the probe. The probe themselves tend to stay in pretty good calibration. You can't recalibrate them in the fields. You have to back adjust the data to what you take with your meter. But generally, it's within 1% of the actual value, which is plenty good enough for what we're after here.
Where would you put if you wanted to get biota right up there under the funnel?
Yeah, where we had our drip collectors before was right under the funnel. The problem with that was that we had colonization going on at the tarp after a year or two. And maybe if we cleaned the tarp periodically, that would have changed things. What we're doing now, you can look back here